So, as I was just mentioning before, if you haven't all people were joining, was that it's hard. There's a lot of different people at different levels at this workshop. So I'm going to give some really basic overview for somebody who's brand new to the topic, and just sort of like goes through some of the terminology and the tools. Then I'm going to hand it over to Chris, who will just give a few slides on the Autograder and the grading. And then we'll turn it over to Yuvi, who will talk about the UC Berkeley Jupyter hubs. And he's also just part of Project Jupyter. And so hopefully he can show us what's going on with Project Jupyter towards the end. I want to say that I've learned a lot from working with Yuvi Panda over the years. And a lot of that's about how building these tools as open source tools and documenting them creates the possibility for things to grow and scale. And for people to be empowered to use the tools, eventually someday potentially contribute to the building of tools themselves. But I know that for myself as an instructor, I learned a lot by being empowered to use the tools in a way that sort of trusts me to learn more and more how things work. So the other thing that's an important note is that to think about is that the way these classes are being taught at UC Berkeley, it's certainly Data 8 is 1,200 to 1,300 students per semester. So there's some aspects of the infrastructure that are important for thinking about how do you get something to be that big and at that scale and work robust at that scale. And that's something that we've been learning over the last 5 years is how those tools work and what those tools need. And I would say when we get to the grading part, grading is a difficult part of this process. And having Chris Pyles here working on the Autograder over the last couple years has been an exercise in trying to make the grading something that anyone at any university in the world can use. Grading is a tough one. We can talk about how it's hard to have a universal solution, but the vision certainly here for the grading is how to have the grader be an open source Python package that can be adapted to multiple possible situations. All right, I'm gonna jump forth here. So every year when we run this workshop, we bring together and we summarize a bunch of our resources for people outside of the university. So 2 years ago, we put together this one-page PDF that had a bunch of stuff on it that was called the Academic Resources Kit that you can still find online. It's still where to start, some of the key packages where you want to start out with. Last year, we did another reboot, data.berkeley.edu/external, and this is a page that we're still maintaining. This is where you should go and find resources, find guides, find discussions of different ways to adapt the infrastructure. So these are 2 starting places that we send people to find where the materials and where the tools are. Now, I'm going to refer back to these materials later, but just to be clear, everything about the Data 8 course, almost everything, is openly viewable. So every time that the course has been offered, you can go to data8.org and see all of the different semesters that it's been offered. Then you can click into an individual semester and find all sorts of stuff here. Now, in many of the semesters, the videos or the slides may be locked to only UC Berkeley. And certainly, if you try and click on the Jupyter notebooks, it would take you to a Jupyter hub that will be locked to only UC Berkeley. But you can see the syllabus, you can see the textbook chapters. And if you know what you're doing, you could see the names of the homeworks and the assignments. And those are publicly viewable on the GitHub page for Data 8. So you should, if you want to find the materials for any given semester, you can go to github.com/data-8, and you can find that semester, and you can find the homeworks, labs, and projects, and you can find what's being pulled in, and just open that in a Jupyter on your own computer, on your own install of Jupyter. Really quickly, if you go to data.berkeley.edu external and you're interested in getting these materials, if you go into Data 8 adoption, there's a place where you can fill out a form to get added to a private repo that has all sorts of materials for teaching Data 8. Now, moving on. Sorry, I switched tabs there. I just wanted, this is a new slide that I just added because we had a new member of the team, and I was trying to help him get his mind around the terms we're using here. So this is like a disambiguation slide. So some of the ways we want to think about Jupyter is, first of all, in Jupyter, there's a file. It's an Ipi notebook file, IPYNB. It's a type of file. This file is a JSON file, which is actually kind of like a database type. What you can have in it is you can have chunks of markdown where you explain something. You can have chunks of code that those can execute. And then you can have the output of the chunks of the code. You can be like, this is how we read in the data set and ask for a visualization. And then we can have a line of code that says read in data set, graph this, and then the visualization will come up. It's viewable. IPYNB files are viewable through this web app in a browser window. What's really important to think about, and I'm going to get to this, I'm going to harp on this a little bit later as well, is this file has really been thought about as something that can work across machines. Like all different types of machines can open this type of file. Another thing to think about is that when we talk about sharing the Data 8 curriculum, a lot of what we're sharing is a set of these IPython notebook files that are very well thought out. John De Niro, who went first today, and and Ani Adhikari and David Wagner, when they were starting the course, were sort of building these curricular notebooks, these rich documents that explain what to do and have little coding exercises that get iteratively more complicated as we go. Those are in this type of file, a Jupyter notebook. Now from there, the next term we're going to say is also called Jupyter Notebook, which is super confusing. We could also call it Jupyter Lab, but there's also a web app that allows us to edit and execute the code within this IPYNB file. So there's one thing that's like the file notebook, and then there's like this web app that allows us to open and execute those files. Open source software project. Anyone can install this on almost any computer. It works through a browser window, so you'll just see, it comes up as a Chrome tab once you've installed Jupyter. It's something that executes those Python chunks, or now they're up to like a couple hundred different languages. Could be R chunks, could be anything, but it executes those code chunks. So that the students in Data 8 are working in this web app to do their homework, to do their labs. Now, another thing that we say is Jupyter Hub. You will hear us say this a lot. And this is a way that this web app can be provided for multiple users. So the students would log on, authenticate into a server, and they will be able to view their notebook files they need to use for the class inside this server. What's important about it is we go back to reproducibility, right? The idea of Jupyter was reproducible science early on, and this is super powerful for teaching. Reproducibility means the teacher writes the notebook, can open the notebook in front of the class, and every person in the class can open the same notebook in exactly the same environment, executing exactly the same way, which is really powerful for teaching computer science or teaching anything where code needs to run. Yuvi, for one of these workshops a couple years ago, made something, the littlest Jupyter Hub, where you could build a little Jupyter Hub, with the free cloud credits that you could get from a cloud vendor. We have a big one that runs on Kubernetes, that runs on Google Cloud, that runs across campus, and we can show some summary statistic about that. And then the other thing is that UC Berkeley also provides Jupyter Hub across the whole campus. So part of my job is going out to do work with outreach, and we're talking to the biology professors, and they're building Jupyter curriculum for their class because this server is available to everyone at the university. One more term that it gets people when I do training, sometimes we say Jupyter Hub, then we say GitHub, then we say Jupyter Hub. GitHub, separate website. Git is a protocol for file transfer and version control, and GitHub is a website service that works with Git, where people do open source software development, and where we could think about this, where we store these Jupyter Notebook files for the class. So the Data 8 class will put up its files on this file server on GitHub, and then use them to teach students through a Jupyter Hub. If this is confusing, feel free to ask questions, and I can, hopefully it will become clear as I do a little walkthrough. So this is how I explain data science teaching workflow to new instructors. So I would say there's several like open source elements here. We have Python itself, we have Jupyter, then we have the Jupyter Hub server, then we have GitHub where we store the files, and then we have interact links where students pull the files from GitHub onto Jupyter Hub. And then in this, I just put another element that we have where we have student developers who help us build all these tools, all these curricular materials. Why GitHub if you have a Jupyter Hub? Well, the reason is that GitHub is a place that can publicly store the materials, that can pull them into each student's Jupyter Hub. So why start with Python? Lots of discussion throughout the workshop about Python versus R for teaching data science. I will just say why Berkeley Data 8, I think, is starting with Python is that it's good for simultaneously teaching the computing and the statistics at the same time. It's nice because it's readable, it's teachable, it seems relatively, it's got a strong future in front of it at the same time. Lots of people in industry are using Python. And then what they have made for the class is a course-specific Python package. And you will see this import data science or from data science import star. They also made another one, a prob 140 package for the data 140, the probability class for data science. The idea here is about making a simpler package for new learners. We've also had various discussions about that, whether students should be directly exposed to pandas or start out with the data science package first. And we can talk about that other places as well. The idea is, though, when you have people in Jupyter Notebooks, you start them off with 1 or 2 packages, but once you're there, you can pull in any number of amazing packages, and that they can, once they're familiar with this workflow, eventually they can be using some of the most powerful tools in data science. Naomi, I think John touched on this earlier, but this is certainly about some of the syntax of pandas and brackets, and things are just a lot simpler in the data science package that look a little more readable, where you don't necessarily have to think about indexing and stuff. Anyone can import data science. It's an open source package, pip install data science. Yeah, so it can be installed anywhere. You will need to install it in certain places because it might not be a standard install, and we can also talk about that later. So the next big element is Jupyter Notebook. As I said, it's a project that's been going for a few years. Many of our collaborators here at UC Berkeley contribute to it. Many different languages can be executed and interpreted inside it. It's made for shareability, which for us is actually made for teaching. And it's interactive, like run code, see the output. Oh, that didn't work right. Run it again, see the output. Run it again, see the output. So it's good for students that it's very easy to work in rather iteratively. And then it does have the possibility of doing bigger and bigger data sets, or running, you can run 1,000 iterations and then you can run 10,000 iterations. So it's very powerful in terms of what you could do once you've learned to expand and do more and more powerful things. Here's just a little view of a Jupyter Notebook. Hopefully you've all been in it in the demo this morning. I also make a little pitch here. This is how I have explained what I do to my mom. There's an idea that perhaps in the future, journal articles are going to be Jupyter Notebooks instead of, a printed PDF. Like, what if people submitted articles to be published and all the tables and graphs in the article could be executed and created with the article itself? I think it's an interesting conjecture about the future. There are some fields of science that are sort of already moving in this way, like the code needs to be submitted for publication in an executable way. So just, I think across universities, there is a revolution going on with reproducible science. How every lab in the university should be bringing reproducible science on. Code and computing should be literate. They should be in a document that other people can see. There should be version tracking. There should be documentation of the data. And there should be the possibility of making a consistent computing environment across people. And so there's definitely a thing here where we're teaching students elements of reproducible science in an intro data science class. But can we sort of add the way that we teach students so that they become students that are capable of doing reproducible work as they go on and become scientists after the class? Okay, so here's a Jupyter Hub. So we have the demo hub that we built for the class, demo.cloudbank.2i2c.cloud. At UC Berkeley, it's called datahub.berkeley.edu. It's a internet address that you go to, and this is the file server view. So if you go in there, you will see any class or any materials that have been pulled in or uploaded. So you can just, see a tree, a viewer of the different files, and then you can open some of those folders and open some of those files. Here's just a graphic, and we'll jump to these later when we get to Yuvi's presentation of the number of different people online every day. This is 24 hours at UC Berkeley and how many different users are on at any given time. You can tell that the students stay up until about 3 or 4 in the morning, and then they don't get up again until about 8:30 or 9 in the morning. But in the middle of the day, there's 500 or 600 users on at any given time. So the other element was GitHub. So again, this is where the course materials are stored. You can go to github.com/data8 and see everything that's been built for Data 8. Another terminology is GitHub is the site, but the folders within the site are called repos. So there's a repo for each semester. That's on the public side. On the course development side, there are private repos that you wouldn't see, but for the external side, and we are working with this one for sharing. That's called Material Spring 20 External. You should be able to find this. And this has a set of public-facing materials that work with the Autograder that we'll see next. Also in GitHub is where the course website is hosted. We can talk about that after. It's also where the textbook is hosted from the Jupyter Book project. So you can make the textbook out of your course notes using the Jupyter Book tool, which converts the Jupyter notebooks into the HTML that becomes the textbook. And this is really powerful for teaching, where you can sort of iteratively be building up the textbook from your course notes. All right, so this is a little tricky special secret sauce here, this thing called the interact link. So what you can do is go to something called the link generator and make a link that opens a specific Jupyter Hub with a specific GitHub repo, and I can even make a path down to the exact Jupyter notebook. And it will make this really complicated link up here. But that's how we distribute assignments out to students. So when you go to the Data 8 site, you would click on Homework 1. Homework 1 would have one of these long, complicated links there. When you click that link, it would invisibly go to GitHub and find that file and pull that file into the directory tree on your Jupyter Hub and open. It could either just show you the tree, or it can open the notebook directly. And so the Data 8 student has no idea that this is happening behind the scenes. They just see that in their browser window, Homework 1 will open. But this is how you as an instructor get the files to the right place so that the students have them. And you can be putting up materials over the course of the semester. Students are clicking link and populating their Jupyter Hub file server with the notebooks they need for that class. So if you think about a workflow, you have assignments. You put the assignments out to the teacher. A lot of people are using Canvas. You could be like Lab 1, Homework 1. You put the link there for Homework 1. Students click the link. It invisibly goes to GitHub. Every student gets their own unique copy of it on their Jupyter Hub. They'll do the work in the notebook, and then they'll save it as PDF or submit it to Gradescope, or submit a zip of the Python and the PDF. There's different ways, and we can talk about submission later. One thing to think about this as an instructor, so you would start by creating materials for the class, getting them from UC Berkeley. Maybe you would change the data set out so that it wasn't about Berkeley, it was about Chicago or Los Angeles or wherever you were teaching. You could go on GitHub and you could make an account and make a repo that's like, fall 2021 data 108. And then you could upload your notebook, the data set that goes with it, maybe the test files that go with it on your GitHub. Then you go and make an interact link. And if you had a Jupyter Hub or you wanted to open in Colab, however you wanted it to open, you would make a link. And then you would distribute that link to the students and be like, okay, students, here's the link to Homework 1. You could send it out via email to a collaborator. You could use Canvas. There's multiple ways that you could use that. And students would click a link and get going on the class. We have another curriculum guide that's sort of like a way to teach other teachers about what we do. Another resource that's sort of like internal to UC Berkeley, but still explains a lot of this workflow that might be useful to instructors at other universities. And then just thinking about it pedagogically, right? Like how we use Jupyter in teaching a class. There is a range of how people think about how to do this, right? So the notebook could be completely written, completely like everything the student needs to do is there. All they do is run the code chunks. One time I tried it out in an very basic intro economics class. I had a completely written notebook where the graphs were just generated, and then students would be asked to like interpret this graph. So they didn't need to know any Python or anything. They just ran something. And then maybe, it's automated with sliders, so they don't even have to change the code. They could just vary something with a slider. So it's, it's just like a web page where they're going to do some interpretation. On the other end, there's other people who are teaching who are like, no, students need to learn everything from scratch. I'll use this platform, but I want them to read it in. I want them to write every command. Maybe I'll give some basics. And then in the middle is like how to scaffold the students. And I think there's a lot of the art of the Data 8 curriculum, or, if you're not going to use this curriculum, it's still artful to go and learn from it, how to scaffold things really well, read in the data set, give a few commands, but then ask the student to do the next thing, how to make it iteratively more complicated. And this is a lot about thinking about our learning outcomes. What do we want the students to be able to do? What's complicated? I think we had a little touched on this earlier today in the community college instructor, giving students wins early on. So have a first few notebooks that are mostly like empowering to the students. Hey, I'm familiar in this. I'm seeing the visualizations pop up before I ask them to do too many complicated things. And that would be calibrating it to whatever students you're teaching with. Another thing to note here, there are what's called Ipi Widgets. So you can make notebooks into interactives, dashboards, pre-coded. You can have multiple things possible. There could be sliders, radio buttons, drop downs. There's multiple things, and they can be really powerful teaching tools when you want to just have the students like interpreting the data and looking at things and not fiddling with coding at certain points. So Ipi widgets are a great place to get creative and make awesome curriculum. So students can still be like seeing things through going into a Jupyter notebooks, but at key points, they could just be interacting with the data through like a dashboard type experience. All right, I would like to bring Chris on to talk a little bit about the Autograder.
Hello, everyone. All right, so I'm just going to talk quickly about auto-grading at scale, and how UC Berkeley auto-grades all of our data science courses. So can you hit the next slide, Eric? So to start off with, the auto-grading solution that we've been developing for the last couple of years, and which is swiftly becoming the kind of standard UC Berkeley autograder after OKPy has been Autograder. Autograder started as an effort fall of 2019 as a way to lower the barrier to entry for autograding for classes at different scales by allowing instructors to autograde assignments in a fully local manner. So, traditional autograders like OKPy require you to have some kind of separate grading server that students submit their assignments to, but then execute and assign a grade. The goal of Otter was to be offline, in that there is no separate server needed. An instructor can just batch download assignments and run everything on their machine. So, it has grown a little bit since then, and Otter is really, at its core, a lightweight, modular, open source autograder that we've designed for scalability. And the core way we do that is by abstracting away autograding internals. The core idea of Otter is really the instructor provides a place to execute, and Otter will take care of the rest for you. So Otter works with both Python and R, and includes tools for assignment development and distribution. Can be executed in a variety of places, as I said, on the instructor's machine, on a remote Jupyter hub, or via a third-party LMS like Gradescope. And then we are currently in the process of developing version 3 of the software. So Otter is currently on version 2.2, I think. And we're going to be revamping it with some new formats and a lot of nice new features. So we anticipate having that version 3 of the software released at the end of the summer. And as David asked in the chat, is this an extension renaming of MBGrader? Something different? This is a different effort. So MBGrader is the Jupyter extension for auto grading, and it's built a lot on. It's built very much into Jupyter as a service, and Otter is not. Otter is kind of its own thing. It's just a Python package that you can pip install, and it is a separate effort. Next slide, please, Eric. So Otter was designed with 3 core audiences in mind, right? So for students, it serves as a guide by providing instructor-written public checks for students' code in real time. So as you probably saw in the demos earlier with the lab, student works on a question, writes their code, and runs the grader.check cell right after to check their work against whatever public test the instructor provides. For graders and TAs, it also includes optionally hidden tests that grade notebooks for correctness rather than just reasonability, and which prevent students from using the autograder as an oracle to kind of brute force the assignment. And lastly, for professors, it was designed to be scalable for grading classes at any scale, and to be compatible with different learning management systems, and whichever one is chosen by the instructor. Slide, Eric?
Sorry.
No worries. So currently, Otter is already being used here at Cal. So Data 100 has been on Otter for the last 3 semesters. It's one of our core upper division data science courses, and it's a very large class of about 1,200 students with a staff size of about 30. It's also being used in a more medium scale class called IOR 135, which is an applied data science and machine learning class, and at small scale in classes like Data 94, which was a data science computing fundamentals class that was started last spring as a very small class of about 20 students. So here's just to give you an idea of the workflow for how Otter gets used. This is the workflow for using Otter with Gradescope as the execution location. And this is the workflow that courses like Data 8 will be using, Data 100 currently uses, Data 88E, I don't know if Eric has mentioned that, but a lot of courses, and all the courses at Berkeley really that use Otter, use this workflow. So it starts off by developing a master notebook. And this is a notebook that contains all of your narrative for the assignment, all of the questions, all of the solutions, and any test cases as code cells in this assignment in a very simple, easy-to-write notebook. And then there's a tool that Otter uses, or that Otter has called Otter Assign, which parses this notebook and gives you 2 different versions as output. One has got solutions in it, and that's for the Autograder, and one has all the solutions stripped, and that's for just giving the students. So then you would take this output, and Otter Assign will also generate for you an Autograder configuration zip file. And this is a zip file that has your tests, all the configurations, and everything needed to configure a grading image. And then you take that file and upload it to Gradescope. So this is all of the pre-release stuff that you need to get done. Now you're ready to release your assignment to students. So you copy your student output version of the notebook and put it onto a GitHub repo and use NB Git puller to distribute your assignment to students. And students would then work through their notebook, use those public checks, and then at the end, export their notebook in a zip file, which they would then upload to Gradescope, right? And then Gradescope just launches a Docker container right when they upload and auto-grades the assignment, shows students the public test output, and then we'll show instructors the private test output as well. Then for manually graded portions of the assignment, you would just use Gradescope's built-in grading interface to do that. There's a couple different ways of doing it, but it's all there using Gradescope. And then finally, release grades on Gradescope's platform and handle regrades there. So that's kind of the overview of how Otter is used at Berkeley. Can we use Otter for regular Jupyter Notebook, not Jupyter Hub grading via Gradescope? Yes. So you don't necessarily have a Jupyter Hub to use Otter. Whatever, if you're running locally, that's fine. Otter is, like I said, it's just a Python package that you can pip install and get going with it. There's no requirement of having a Jupyter Hub. Gradescope is how we use it at Berkeley, but it's not required, right? You only need a place to run the assignments. So what you can do is you can use Gradescope, as I've been talking about. You can, you have Docker installed on your computer. You can download the student submissions in batch and use Docker on your local computer. So Otter has a tool in it called Otter Grade, which will take in like a bunch of submissions and then launch separate Docker containers itself to grade each of these assignments. So this is like a local containerized grading that doesn't require Gradescope. And you can also run local grading in a non-containerized way if you don't have Docker. So this is like a situation where you want to run, instead of running on your computer, you want to run on like a Jupyter Hub account or something, or you want to run in a place where you don't have access to Docker, then you can also just run on your local file system without containerization. Otter and Gradescope will work with Colab. Yes, there are a couple of kinks we're working out with Colab at the moment, but yes, it does work theoretically.
Importantly, we're working on it.
Yeah, it's almost done. I think there's like one issue currently about exporting, but if you download, so Otter, you can just pip install in Colab, and then if you just download the notebook using Colab's interface and upload it to Gradescope, you'll be fine. It works as expected.
And come to the next session for that question.
Does Gradescope and Otter enable you to run Autograder often? Yeah, so Gradescope lets you rerun the Autograder as many times as you want. They don't have any rate limiting or anything. And it's run when the student submits. So as soon as the student submits, the auto-grading process is launched, and they get that kind of almost immediate feedback after their auto-grader finishes running, and instructors can go in and see the results of those hidden tests as well.
Let's hand it over to Panda. Thanks, Chris.
Yep, no problem.
Hey, Yuvi.
Hey, thanks for moving us along, Eric, and thanks for that, Chris. So I'm Yuvi. I'm part of the Jupyter Hub project. I'm one of the core maintainers. I work on cloud infrastructure, and I've been part of the team helping run Berkeley's data hubs for like a while. So this is going to be like a quick slideshow plus some. Here we go. Okay. So I mostly want to talk a little bit about the scale of what we run, what exactly people at Berkeley have access to, students and instructors, and a little bit of like what next steps are if you want to get something like that. So this is for the semester just finished. We have 12,477 users used it throughout the semester. I think last time was 10,000, so that's like a bunch of growth because I think pandemic forced a bunch of classes to move online faster than anticipated. And this works out to about $3 per semester per student on cloud costs. So we were hoping this would be cheaper. It's been like consistently reducing over time, but we had some very compute heavy classes from EECS this semester. So it's still at $3. So, but hopefully next semester we'll bring it down to $4. The open source community and us, we've been working on doing this kind of cost reduction. And this was, like on like 2,500 users, like, almost every day. And we've had like 4,600 users at max at a single point of time. You can see the dip on the weekend, and you can see spring break. And you can see that this is like a fairly consistent usage pattern. This is like across all of the hubs that we maintain. And Shashank, who's one of the students who works with Eric, he actually did this for Data 100, which is just one of the classes. And you can see how different homework assignments, like there is definitely a peak as, of course, students try and get that done just before it's due. And like this gives you a lot of data. Like for operational purposes, we collect a lot of data about the system itself, and hopefully over time we can feed this back into the classes themselves, so people can like almost real time do a bit of data science on what it is, the infrastructure they're running it on. But we actually have no idea how many classes are using it. We have like a very rough idea, but not really. This is on purpose for the most part. The goal is for it to be extremely easy for any instructors, for any TAs, for even any students to be able to start using it. We don't want that to be a gating process. We don't want to have people come and ask us for permission. We don't want to be like the bottleneck in this space. So this means that like there are a lot of classes using it, and sometimes we only find out when they come to us with a problem. And we are like, oh, that's great. We didn't know you were using it. And that's, I think, helped us grow very fast over the years, because it means that students themselves are often people who bring it to their other classes because they're like, we use this in this class, it's nice. And then they became TAs, so it's sort of like a coalition of the willing that pushes this through in various places. And it doesn't just have, this is one of the confusions that Eric talked about earlier, like the classic Jupyter notebook is what people normally think of as a Jupyter notebook. But of course, there are many different ways you can access this. Like, like Google Colab as an example is another UI, but there is also Jupyter Lab, which is like a more modern version of Jupyter notebooks. But we also run RStudio. Like, we want to support R as a first-class citizen. in all of the instructions that we do from an infrastructure perspective. And that means, you have to run RStudio. So the same Jupyter Hub infrastructure, we run both Jupyter notebooks, which, if you have tested out the demo, you could see it earlier, but we also run RStudio. So I just wanted to very quickly show that. So this is, I'm just going to go to the R Hub, which is the Jupyter Hub that Berkeley runs, that is primarily R. And if you log in, it asks me to log in with my credentials. Cycle. Make sure that I really want to get inside. And then, this is the same Jupyter interface that you saw otherwise, but hopefully this should get me into RStudio. So users can, not just run Jupyter without having to install anything, but also, oops, I must click something wrong somewhere. But anyway, even if I'm here, I can go to new and select RStudio, and that will put me inside RStudio. So you can switch back and forth between Jupyter and RStudio and use the same underlying infrastructure for all of that. So any files I have here will be available there and vice versa. So it's basically the same as running it on your own machine. So yeah, another thing that I wanted to talk about is, that because this is all fully open source, one of the great things with that is a lot of times the tools themselves derive from problems that we want to solve for our instructional use case. So one of the other things I wanted to demo was real-time collaboration in the Google Docs sense of the sense. I know that for a long time, that's been really something people wanted to help, just to, help people debug issues when they run into problems. So you don't have to go back and forth talking to each other. So I just, this is almost ready. This is available on Jupyter Lab and this classic notebook style looking application called RetroLab. And we are hoping to use this in Data 8 the coming summer a little bit and, see how it goes and get more people to use it. But I just wanted to have a very, very quick demo of this real-time collaboration. This is lab 2 from earlier, if you were in the session earlier. And this is just, I'm just running notebooks, running cells, doing normal things that you would normally do. And there is something here where it's asking me, to I think it was asking me to do something particular. It was, I think, trying to get me to do this formula, which is e to the power of pi minus pi. So I, can do something like pi minus, and okay, that's wrong. And okay, so at least there's no syntax error, but this tells me that it's wrong. Now I'm not, Otter gives me reasonable results, but in this case, if I was in a physical space, it would be very useful for me to just go talk to someone and then they can come look at my screen. And so with real-time collab, we can instead, so the idea is that it's a share link, and I can get this link. It's going to give me a link that I'm going to copy, and then because it's demo software, I had to fudge this link. So you don't have to do this in a couple of weeks. And then I'm going to talk to Sean Morris, who is someone who I work with, but we're role-playing the idea that he might be someone who's a TA. And so I can be like, hey, Sean, I am having trouble with lab 02. Can you help take a look? And then I can just send him the link and say it's Q2. Can you tell me what is wrong? And so when he clicks the link, he's going to actually, so you can see him typing. I'm not typing, my hands are out of the screen. So he can see that he can actually come see what's happening here. And then he can type through with this. And I can as well, just to show you that multiple people can be typing. Oh, I can't change the grading cell, but I can type as well while he's also typing. if I want to do that, so you can actually truly collaborate. But you can see that he's come and changed the code, and then now I am right. So he's executed it, and now I'm like, oh, and then now I can execute it, and I can then finally run the test, and it's worked. And then I can go and say, thank you, Sean. That was helpful. Anyway, so this whole setup, it was like there is a lot of feedback. We are like doing it at a very tight iteration circle, and hopefully this will be very helpful in not just distributed cases, but like pretty much for people collaborating and for people helping people get unstuck and all those kind of use cases. So we also have Julia and like a lot of other things that we support, and not just like Jupyter notebooks. There is like a Linux desktop demo that we're not going to get into, but it basically gives you a full Linux desktop on your browser that you can do Linux desktop things with. At Berkeley, we have, I think, 10 or maybe 11 hubs. We can make a new hub pretty fast. It doesn't actually affect our total resource usage or anything a lot. It's helpful because there's the idea of admin access. So if I go to control panel, I can actually look at other people's work. We have too many users. I can look at other people's work, and then I can help them debug, I can do a bunch of things, and we only want we don't want everyone to have it for everyone. So we can do that on a per hub basis. And you can see that the R hub had RStudio by default, and the main data hub has Python. Social signaling is also important. Having a separate R hub that opens by default into RStudio, I think helped us get a lot more R instructors and students onto the hub, because there is a very strong perception that Jupyter Hub is just for Python, Jupyter is just for Python. So having something separate, I think, helped bridge that gap. And that was helpful. And of course, making new hubs is very easy for us because we have like set it up in that way. Our code is like completely open source and open infrastructure. All of our deployment scripts are public. We run it in like the entire spirit of open source, and you can see that people are making changes throughout. Like, so this is all, and we do deployments all the time. Even in fact, the demo hub, the CloudBank demo hub that was used today, there was 4 deployments to today. We feel fairly confident with our deployment infrastructure that we just basically, for the most part, do that as we go. And lots of people have contributed to it, but there's only 0.5 full-time folks from Berkeley working on both new features and upkeep of the hub. So that's some part of my time and some part of Jonathan Felder, his time. And we interact with each other, but we also work with the broader open source community. So most of the updates and new things and bug fixes that we do benefits the open source community at large, and vice versa. So we try very, very hard to make sure that that's how it is. And again, these are some of the techs that we use. We currently run on Google Cloud, but we have run on Azure in the past. We've run on bare metal systems in the past. We try really hard to not be tied to any one cloud provider, so we can always both so that the open source community can benefit from the work we do, even if they are not exactly running the same things that we are running, and vice versa. But also so that we don't get super tied into one cloud provider, and we can always move for whatever reason that we need to in the future. So, and one final note is to the Littlest Jupyter Hub. I think Eric pointed this out earlier. This was built for one of the workshops, I think maybe 2 years ago, and has gone on to become a part of the broader Jupyter Hub ecosystem, and has become very popular. If you only have a small number of students, I think then this is like a fairly easy way to get up and running. I think Howard used it, but there's also now 2I2C offering these as like a managed open source setup. If I think there's going to be some people talking about it at the vendor expo tomorrow. But yeah, that's what I have. This is an email that goes to the people who run the infrastructure at Berkeley. So if you're interested, you can send emails there and talk to us. So I think that is what I have. Thank you.
Thanks, Yuvi. Yeah, so a couple of people are asking, if they need to teach Data 8 at their university, do they need to build a Jupyter Hub at their university? Tough question. Depends on what your university has. We will cover some of this in the session later today, but you can build your own hub, as Ross is putting the link in, or as Yuvi just said. You can use a commercial vendor. You could use Google Colab. You could use, we're also going to show another one, Deep Note. That's just like another one who's, free for instructors. There's, federated hubs like the 2I2C hub that would be like across universities. You could talk to them. If you're a California community college, we have a pilot to provide hubs to them. There's multiple ways to get Jupyter hubs going at different places. But yeah, it is a question. There's technological choices to be made. There's, if you pay more and get a vendor, you're going to get more service. If you roll it your own, you're going to have to figure out certain more technological choices. So there's multiple ways. Brings a lot of advantages to the teacher, but is required. Certainly, it's becoming increasingly popular. Yuvi and I had a conversation, like, for example, with the person from Harvard, I don't know, like a month ago, and just going over like how much they supported like 2 or 3 classes, and now they support, I don't know, like 20 or 30 classes. And, their IT at campus at Harvard is like expanding the amount that they offer in Jupyter Hub. So some of it's like find the awesome person in your IT side, and if you could find somebody, see if they're interested in deploying this technology. It's free, the software itself, but the cloud's credits do cost. There's definitely ways that the cloud vendors give away cloud credits for education. We can talk about that. Any more questions? This funny thing, you have to monitor chat and Q&A. How many people can TLJH handle? That's one to you, Yuvi. It can go over 100, but it just becomes ungainly.
There, the 100 is mostly so that if you want to have one big virtual machine for, let's say, 200 people, you might get something that's 200 gigs of RAM, which might mostly not be used. While if you get something that's running on Kubernetes, it's a little bit more complex to manage, but it can go up and down. So when it's not being used, it will not cost a lot of money. So that's where it's helpful. But if you maybe have physical hardware, or if you're just running free credits, you can totally just use little Jupyter Hub. 250 people should not be a problem.
Yeah, I mean, one thing to think about, Benedict, like if you were running a workshop for 2 hours, and as you'd be saying, like you could build this machine that could handle the people as long as you were able to close it again after 2 hours. If you were going to set this up and just leave it open for a while, it would be a big machine to leave open for a while.
Mark has a question of, is it difficult to customize the environment for a Jupyter Hub? So this is one of the other big differences between Little Jupyter Hub and Zero to Jupyter Hub. With Little Jupyter Hub, it's if you are an instructor and you just run conda install or pip install, it will be immediately available to all students. So that makes customizing the environment very, very easy, because it's exactly the same as how you would do it on your local machine. With Zero to Jupyter Hub, it is definitely a little bit more difficult, but there is a lot of resources out for doing that. But yeah, it is definitely a little bit more difficult. You have to have at least some understanding of Git and a repo Docker or something like that to be able to do that.
Nice.
And Eric, there's a question about the community college pilot.
Follow up with me, or write to dshelp@berkeley.edu, and we can follow up with you directly. Yeah, we're supporting a few community colleges. If you went to the session before, El Camino, they taught 3 sections of Data 8 on the Cloud Bank Hub this last semester. And Gloria from Howard taught on the Pilot Hub as well, on the 2i2c hub in our ongoing pilot.